today we start new topic, vector product of two vectors. So consider here two vectors, vector A and vector B, and angle between them is theta. Then we see the definition of vector product. Let A bar and B bar be two vectors and theta be the angle through which A bar must be rotated about O so as to lie along the line of B bar. That means we rotate this vector A about this fixed point O such that this vector A lie along vector B. So cross product of this vector A and vector B is denoted by A bar cross B bar. Now this vector A bar cross B bar, if you observe, this vector is perpendicular to both vector A and vector B. Actually this is we already discussed while solving the problem in exercise 5.3. First question we solve by using the definition of vector product. So we discuss points related to it. Then the vector product of vector A and vector B is defined as the vector which is of magnitude AB sin theta. Second, perpendicular to both vector A and vector B, that is perpendicular to the plane of vector A and vector B. And third, in the direction in which a right-handed screw would advance when it is rotated from vector A to vector B. This is a right-handed screw system. So we discuss the points related to this vector product. Also while solving the problem, just we have to remember the definition. So we can write vector A bar cross B bar as magnitude of A into magnitude of B into angle between them measured in sine and unit vector along the vector A bar cross B bar. So see here, the vector product of vector A and vector B is denoted by A bar cross B bar. So we read as A bar cross B bar, and is also called cross product. This vector product is also called cross product. Thus, if n cap is the unit vector in the direction perpendicular to the plane of A bar and B bar, so that A bar, B bar and n cap form a right-handed system, then we write A bar cross B bar equals to magnitude of A into magnitude of B and sin theta, that is we measure the angle between these two vectors in sine ratio, and n cap into n cap. This n cap is unit vector in the direction perpendicular to the plane of A bar and B bar. Now we discuss property of vector product. Number 1, if vector A, vector B are collinear, that is parallel, then theta equals to 0. We know that A bar cross B bar equals to A bar cross B bar equals to AB sin theta into n cap. So when this theta equals to 0, that means when vectors are parallel, then angle between them is 0. So we get sin 0 as 0. So their cross product is 0. That means when two vectors are parallel, that is collinear, then their cross product is 0. Not only 0, 0 vector. Thus two non-zero vectors are collinear if their vector product is 0 vector. In particular, A bar cross A bar equals to 0 vector. So I bar I cap cross I cap equals to J cap cross j cap equals to k cap cross k cap equals to 0 vector. In scalar product, we know that I dot I is 1, j dot j is 1, k dot k is 1. Here cross product of like vectors is 0 vector. We write here a bar cross a bar equals to 0 vector. So unit vector also I cap cross I cap, j cap cross j cap, k cross cap k cross equals to 0 vector. So now see second property. I, j, k are three mutually perpendicular vectors. We know that in right-handed screw system, I, j, k are the unit vectors which are mutually perpendicular to each other. This unit vector I is along x-axis, this unit vector j is along y-axis, and this unit vector k is along z-axis. That means we know that x-axis, y-axis, z-axis are mutually perpendicular to each other. So the unit vector along them is also mutually perpendicular to each other. Therefore, I cap cross j cap equals to, we write by definition, magnitude of I, which is 1, magnitude of j, which is 1, into sine of angle between them. We know that angle between x-axis and y-axis is 90 degree because they are perpendicular to each other. So theta equals to 90 degree into unit vector. Now I cross j to x-axis, y-axis, z-axis is perpendicular. So we consider unit vector along z-axis, which is k. So we write this first three terms as 1 because sin 90 is 1. So 1 into 1 into 1 we get 1. 1 into k cap we get k cap. That means when two different unit vectors, their cross product is always the third unit vector. So we see here I, j, k. So in cyclic rotation we can find the next. Similarly, j cap dot k cap equals to I cap, and j cap cross k cap equals to I cap, and k cap cross I cap equals to j cap. When we consider this cycle in clockwise direction, then we get the positive value. When we consider in anti-clockwise direction, we get the negative value. That means when we take k cap cross j cap, then we get that value as minus I cap. Now see third property. A bar cross b bar equals to magnitude of A into magnitude of B into angle between them in sine ratio, that is sin theta into n cap, where n cap is the unit vector perpendicular to the plane of A bar and B bar, so that vector A, vector B and unit vector n cap form a right-handed set of vectors. Now see here. Now the vector b bar cross a bar has magnitude b into a into sin theta, is perpendicular to the plane of b bar and a bar, but it is in the direction opposite to that of n cap. Since now b bar, a bar and minus n cap form a right-handed system, hence b bar cross a bar can be written as magnitude of b, magnitude of a, we write here magnitude of b into magnitude of a, and angle between them is sin theta. Here the unit vector is in opposite direction, so we write minus n cap. So when we write this RHS taking minus sign common, so we write here AB as BA as AB, so we write AB sin theta into n cap. So this is value of a bar cross b bar. So from this, when we take a bar cross b bar, it is not equivalent with b bar cross a bar. That means vector product is not commutative. Since I cross j equals to k cap, we have j cap cross I cap equals to minus k cap. That means from above discussion we say only vector product is not commutative. We know that scalar product is commutative. Here vector product is not commutative. That means I cross j not equivalent with j cross I, because I cross j is k cap and j cap cross I cap is minus k cap. Now see fourth number point. Magnitude of a bar cross b bar equals to magnitude of a bar cross b bar equals to ab sin theta. Therefore, when we have to find the angle between two vectors using sine ratio, we find angle as sin theta equals to magnitude of a bar cross b bar upon magnitude of a into magnitude of b. So while finding the angle between the two vectors in scalar product, we use cos theta equals to a bar dot b bar upon magnitude of a into magnitude of b. Here we take the magnitude of cross product of vector a and b. So remember this formula for finding the angle between two vectors. See the fifth number point. Since a bar cross b bar equals to magnitude of a into magnitude of b into sin theta into n cap, therefore we can find unit vector from this. So when we have to find the unit vector which is along the vector which is perpendicular to both a bar and b bar, that is vector a bar cross b bar, then we can find that unit vector by using this formula a bar cross b bar upon magnitude of a and b into sin theta. That is, we replace this ab sin theta by magnitude of a bar cross b bar. So this is again definition like magnitude of unit vector along a bar as a bar upon magnitude of a bar. So we find the unit vector along a bar cross b bar. That means we write unit vector along a bar cross b bar which is denoted by n cap and a bar cross b bar upon its magnitude. Since b bar cross a bar is not equals to minus a bar cross b bar, therefore unit vectors perpendicular to both a bar and b bar are. So we get two unit vectors same in the direction a bar cross b bar or opposite in the direction a bar cross b bar. So we write here plus or minus. Now see expression for a bar cross b bar in terms of I, j, k. This is important because we use for solving this problem from the exercise. So consider here vector a as a1i, b1j, c1k and vector b as a2i, b2j plus c2k be two vectors. Since I cross I, j cross j, k cross k equals to 0 vector and I cross j equals to minus j cross I equals to k cap. So from this we can write a bar cross b bar in terms of determinant. See how to write that. So first we find a bar cross b bar. So we substitute the value of vector a as a1i, b1j plus c1k and value of vector b as a2i plus b2j plus c2k. Now multiply by vector or multiply by a1i to each term of second bracket. So we write here a1 into a2 I cross I, then a1 into b2 I cross j, then a1 into c2 I cross k. Similarly multiply by b1 to each term of second bracket. So we write here b1 a2 I cross I, b1 b2 j cross j, then b1 c2 j cross k. So in this way we multiply by C1. So C1 A2 K cross I, C1 B2 K cross J, C1 C2 K cross K. So now we substitute the value of I cross I, J cross I cross J and I cross K. Similarly J cross I, J cross J, J cross K, K cross I, K cross J and K cross K, as we write here I cross I, J cross J, K cross K as a 0 vector. So we get here this first term as 0. So we directly write this second term because I cross I is 0 vector. So we write here A1 B2 I cross J and I cross J is K. So we write here K. Then A1 C2 I cross K, I cross K. So we write I cross K as minus J. So we write here minus sign. Then for this B1 A2 J cross I, J cross I, here J cross I we write minus K. So we write here minus sign. Then for this B1 B2 J cross J, this vector is 0 vector, so we not write. Then B1 C2 J cross K. So J cross K is I. So substitute that vector as I. So we write its coefficient plus. Then see the next value C1 A2, C1 A2. So C1 A2 K cross I we replace by J. So we write plus sign C1 A2 J. Then next value we write here C1 B2 K cross J. This K cross J which is minus I. So we write here minus sign minus B2 C1. This minus this J cross I or K cross J as minus I. So we write here minus sign. Then last term K cross K, this value is 0. So we write this as. Now see the like terms K cap, K cap, J cap, J cap, I cap, I cap. So we take I cap common, J cap common and K cap common. So we write first unit vector I cap. So see the first positive term, that is B1 C2. So we write here B1 C2. Then minus term B2 C1. So we write B1 C2 minus B2 C1. Then next J. So C1 A2. Then this minus A1 C2. So taking common J we write C1 A2 minus C2 A1. Then see the unit vector K, A1 B2 minus B1 A2 K cap. Now if you observe this, this is the determinant form. So when we solve this determinant, in first row we write ijk, then in second row we write the coefficient of ijk of first vector, and in third row we write the coefficient of ijk of second vector. So if we solve this determinant by writing plus minus plus, you get the value, that is this last step. So from this we can say A bar cross B bar equals to, in determinant in first row ijk, in second row we get A1 B1 C1, and in second row A2 B2 C2. So when we have to find the cross product of two vector, by using this determinant also we can find the cross product of that two vectors. Thus A bar cross B bar can be considered as the vector area of parallelogram whose adjacent sides represent the vector A bar and B bar. So in remark, area of parallelogram equals to magnitude of A bar cross B bar. The next topic is vector area of triangle. So by using vector we can find the area of triangle. So consider here triangle ABC whose position vectors are A bar, B bar, C bar. So see, Let A bar, B bar, C bar be the position vectors of the vertices A, B, C of triangle ABC respectively. So we find cross product of vector BC and vector BA. So if you observe, we consider this vector BC and vector BA. So we write by definition magnitude of vector BC into magnitude of vector BA into angle between them. Suppose we consider angle between vector BC and vector BA is B. So we write sin B into unit vector which is perpendicular to both BC and BA, that is perpendicular to the plane of BC and BA, where n cap is the unit vector perpendicular to the plane of triangle ABC. So we consider here that unit vector is perpendicular to the plane of triangle ABC. Now area of triangle equals to half into BC into BA into sin B. This is half the magnitude of vector B bar vector BC cross BA. So we calculate here value of vector BC cross BA, that is BC into BA into sin B into unit vector. When we take magnitude, so we write here area of triangle ABC equals to half into BC into BA into sin B, that is the magnitude of this. If we take the magnitude of this vector and observe with it, it is half. This is the half magnitude of vector BC cross BA. Thus half of BC cross BA can be considered as the vector area of triangle ABC. Hence vector area of triangle ABC equals to half of cross product of vector BC and BA. So if we know the position vectors, so this vector BC we write position vector of C minus position vector of B, and this vector BA as position vector of A minus position vector of B. Now multiply these two brackets, so we get here C bar cross A bar minus C bar cross B bar, then minus B bar cross A bar minus minus plus B bar cross B bar. So we use the property that A bar cross A bar equals to 0 vector. So we get here this A B bar cross B bar equals to 0 vector, and we can write this vector B bar cross A bar as minus, when we write this B bar cross A bar as A bar cross B bar, so we can change its sign. So we write here this minus C bar cross B bar as B bar cross C bar. So we replace that value. So this last term get 0. This minus C bar cross B bar, we write B bar cross C bar. So substitute the value. First value we write here this C bar minus B bar cross A bar as A bar cross B bar. So we write this value. Rearrange that values. So we write in cyclic order A bar cross B bar, then B bar cross C bar, then C bar cross A bar. So we remember vector area of triangle ABC equals to half of AB bar cross AC bar. Therefore area of triangle ABC equals to half of modulus of AB bar cross AC bar. That means when we consider vertex A, then this AB AC. When we consider vertex at C, then we take CB CA. So in this way we can find the vector area of triangle.